Assalamualaikum warahmatullahi wabarakatuh. My name is Khasidah Binti here. My metric number is F1800204 and I'm going to present for introduction. So for this project design, a stadium is a place where events are held. Those events including outdoor sports or formal events. So the design for each stadium is all based on each components that the stadium has, including the choice of materials and that is used in every component of the stadium. So for this design, the steel grade chosen to be used is grade S275 with a stated universal beam, universal column, and universal angle dimension that are conclude in purlin design. So as for the truss, its length is chosen to be 8 meters long and the type of truss chosen is pratt truss. Next. So the choice of truss design and engineering judgment. Truss is an arrangement of bars or members connected at joints or nodes that create a rigid structure behave as a single object. So the mean of truss is to achieve an even longer span that reduce deflection and support heavy load. It will also minimize the weight of structure. For this project design, pratt truss are most suitable to use for a stadium construction. Pratt truss is often used in a long span building with the span ranging from 20 meter to 100 millimeter. And trusses are basically made up of three basic elements: a top chord, which usually compression, a bottom chord, which usually tension, and a bracing between top and bottom chord.
So for the next part is chapter 2, which is the design overview. This picture shows the simplified layout in AutoCAD of the truss for the stadium design that we choose. Load computation. For the selection GK, QK, and WK, the truss FA is 0.767 kN per meter. For the top chord, GK is 4.4 kN per meter, QK is 4.8 kN per meter, and WK is 5.2 kN per meter. For the bottom chord, FS roof is 8 kN per meter. So the total GK is 13.17 kN per meter. QK is 4.8 kN per meter and the total WK is 5.2 kN per meter. After we get the total value of GK, QK and WK, next we calculate the load cases ultimate limit state ULS and the serviceability limit state SLS. Determination of truss use. Choices of truss shape and dimension. We use the pratt truss in this project. The height is 0.8 meter and the truss span is 8 meter. So we choose the pratt truss because the vertical members are in compression while the diagonal members are in tension. This simplifies and produces a more efficient designs in the steel in the diagonal members can be reduced. This has a few effects, which is reduce the cost of the structure due to more efficient members, reduce the self-weight and eases the constructability of the structure. This type of truss is most appropriate for horizontal span, where the force is predominantly in the vertical direction. So for the connection types, we use the bolt type. There are a lot of advantages using the bolt type, such as use of unskilled labor and simple tools, noiseless and quick fabrication, no special equipment or process needed for installation, and also fast progress of work.
For determination of truss manual calculation, this is the stated calculated result. So for the top chord, we use an ED of 966.5 kilonewton of compression with sizing of SHS 200 times 200 times 10. We still get 275. The result of top chord is satisfactory because NED is smaller than NBRD. The result for bottom chord is also the same. And for internal member, with an ED of 425.1 kilonewton with compression tension member, using size of RHS 120 times 60 times 5, a steel grade of 275. The NED is smaller than NBRD, therefore our internal member is also satisfactory.
Hi, my name is Nurul Malik. I'm going to present for the Step Pro analysis. Analysis was done in the Step Pro software to see the difference in load values at internal members with the manual calculations. These values of loads calculated in this chapter will be used in chapter 4, which is to design tension and compression truss members. This is the result from the step 1 analysis. As we can see in the screen now, the load from the step 1 analysis is all in negative values, which means that all of the internal members are in tension.
Hello and good day to Doctor. My name is Wani Binti Edros and my matrix number is CF1886. I will present about a roof truss. The slide show a truss design procedure, which is a basic knowledge that we must know before we all proceed a design. A design per links. As for information, we all use DBS 5950, which is buku orange yang kita selalu guna dalam kelas for design per link. This is a table of polling that show angle or CHS or RHS, which is suitable or not. We use the different three type of purlin. A design of compression member. First, we must find the cross-section properties. Second, we must determine the class of section in uniform compression, and three, determine the resistance of the cross-section. And lastly, the buckling resistance in and out the plane of the truss needs to be determined. So all the process we must refer a book BS 5950. Design of compression member. This is a diagonal member. This is the palang. It show a diagonal member, and vertical member is a member which is located vertical between upper chord and bottom chord. The vertical member is the vertical that I show, if you can see. Yeah. So the data of tension and compression I take from a manual calculation, which is a value we take from a step pro, and then we calculate manual calculation, and then I take out the internal force from the manual calculation, and then I categorize which the tension, which of the compression. If positive, it is the tension. If negative, it is compression.
Hi, my name is Nurul Nadia Malik. I'm going to present for the design of connection. Connections are used to transfer the forces supported by a structural member to other parts of the structure or the supports without any failure. The connections may use bolts or end weld, and sometimes you need to include steel plate in the design. The connections are depending on the type of loading, strength and stiffness, economy and difficulty, or ease of erection. For this stadium, we are using bolt connection design. The specification of the bolt is as stated in the screen. This is the minimum and maximum spacing and edge distance for the bolt. And this is the diagram after we calculated the minimum and maximum space distance and the end and edge spacing. This is the calculation for shear resistance of the bolt, which we found that the design shear resistance can be used. This is the tension resistance calculation for the bolt, and also the tension resistance design can be used. And this is the combined shear and tension calculation. Lastly, this is the detailing of the bolt and the plate. That's all for me. Thank you.
For the conclusion, we use the STEP Pro to enhance and help us to develop of our ability and knowledge in civil engineering application, particularly in the design of steel structure. For the manual design is computation of each structural element, including the truss purlin and connection between the members also that are required in this project. The steel structure must be designed in according to the Eurocode 3. For the load that act on the top part of this structure steel design is 966.5 kilonewton, that is compression member. For the bottom part is 1160.6 kilonewton, which is tension members. And lastly, for the internal members, the load that acting on this part is 425.1 kilonewton, which is tension members. This is for the details of sizing of members, which such as purlin, top cord, bottom cord, internal members, and connection. That's all from us. Thank you.